In this session, we are now going to solve a few questions based on arithmetic progressions. Let us take care of the first question now. If the 10th term of the AP is 52, so let us underline what all is given to us. It's given that the 10th term is 52. So let A be the first term. Let A be the first term of the AP. First term of AP, and let B be the common difference. B be the common difference. So now we know that the 10th term, that is T10, is equal to 52. T10 is given by A plus 9D. So A plus 9D is equal to 52. This is the first equation. And the second equation, the second condition here is the 17th term, that is T17, the 17th term. The 17th term is 20 more than the 13th term. That means T17 is 20 more than T13. The 13th term is T13. Now the 17th term is given by A plus 16D is equal to 20 plus the 13th term is given by A plus 12D. Now the term A and A cancels, and therefore you get 16D is equal to 20 plus 12D, right? And therefore 4D is equal to 20, which means the value of D is equal to 5. So the common difference is 5 for a given AP. This is what we can conclude from the second condition. Now if the value of D is 5, I can substitute D is equal to 5 in the first equation. So what I get is substituting D equals 5 in say the first equation. What we get is A plus 9 times 5 is equal to 52, which means A plus 45 is equal to 52, and therefore I can say that A is equal to 7. So the first term of the AP is 7 and the common difference is 5, and therefore I can say that the AP is first term is 7, then the next term is A plus D, that's 7 plus 5 is 12. Then the next term is increment this by 5, so you get 17. Then again add 5, you get 22, and so on. So the AP is 7, 12, 17, 22, dot, dot, dot. These are the terms of the AP. So again over here, using the general terms formula, we were able to derive the two conditions that were given in the question, and then it was just a question of solving those linear equations, right? So this is how we solve this particular question. Again, pausing for a minute before moving on to the next question. Moving on to the next question. Let us take a look at the following question. The difference between the 9th and the 18th term of an AP is 45. So it's given that the difference between T9 and T18 is equal to 45, which implies that T9 minus T18 is equal to 45, right? Now the value of T9 is going to be A plus 8 times D. We know that the general term is Tn is A plus n minus 1D. So the 9th term is going to be A plus 8D minus the 18th term is going to be A plus 17D, and this is equal to 45. So if I open the brackets, I get A plus 8D minus A minus 17D is equal to 45. And A minus A cancels, so 8D minus 17D is minus 9D equals 45. And therefore D is equal to 45 divided by minus 9. And that is equal to minus 5. So the value of common difference is therefore minus 5. Now we have to find the difference between the 10th term and the 100th term. That is, what is asked is we have to find the difference between T10 and T100. So that is, we have to find T10 minus T100. Now T10 is given by A plus 9D and T100 is given by A plus 99D. And now when I find the difference, I get A plus 9D minus A minus 99D. Now A minus A again cancels and therefore this becomes minus 90D. Now the value of D is known, so this is going to be minus 90 times minus 5, which is 450. And hence I can say that the difference between the 10th term and the 100th term is 450. So just to explain this one more time, it was given that the difference between the 9th and 18th term, that is T9 minus T18, was basically 45. I simply use the substitution for T9. So T9 is going to be A plus 8D and T18 is going to be A plus 17D. This difference was equal to 45, which meant that D was minus 5. A cancelled from the left hand side, and that is why D was negative 5. Now we have to find the difference between T10 and T100. So T10 was A plus 9D and T100 was A plus 99D. So that to find the difference, I do A plus 9D minus of A plus 99D. So when I open the bracket, I get A minus A cancels and 90 minus 99D is minus 90D, which is minus 90 times minus 5, and that is positive 450. Right? So this is how I solve this particular question. Again, pausing for a minute before I move on to the next one. Moving on to the next question. Determine the 10th term of the AP from the end for the AP 4, 9, 14, 19, so on till 254. So the given AP here is 4, 9, 14, 19 till 254. Now for this particular AP, we want to find the 10th term from the end. So what I'm going to do is, of course, for this particular AP, the first term is 4 and the common difference is 9 minus 4, which is equal to 5. Now if I reverse the AP, let's understand why I am reversing the AP. See, I want to find the 10th term from the end. So if I make 254 as my first term, then I basically have to find E10, right? So I'm reversing the AP. So when I reverse the AP, this particular sequence becomes 254. Then the next term is going to be 249, then 244, and this will continue till 19, 14, 9 and 4. You will notice that this particular sequence is also an AP, right? Where the first term is 254. So A is 254 and the common difference becomes 249 minus 254, which is minus 5. So you will notice that the last term of the given AP became the first term of the reversed AP, and the common difference of the given AP was negated to get the common difference of the new AP, right? So this is how I can flip the given terms, and now I have to find T10. So T10 basically will be given by A plus 9 times D. Now A is equal to 254 plus 9 times D is minus 5, and therefore this is 254 minus 45. Now 254 minus 45 is going to be 209. Therefore I can say that the 10th term of the AP, from the end is equal to 209. This is how I can find this particular answer. So again, pausing for a minute before moving on to the next question. The key idea here is that when you reverse an AP, the last term of the given AP becomes the first term of the reversed AP, and the common difference of the original AP becomes, it negates itself and it becomes the common difference of the reversed AP, right? So these are two important ideas that we saw in this particular question. Again, pausing for a minute. Moving on to the next question. Which term of this AP will be 132 more than the 54th term? So in the given AP, I can say that in the given AP, the first term is 3. The common difference is 15 minus 3, which is 12. And now I want to find which term is 132 more than the 54th term, that is more than T54. So let us assume that let Tn be 132 more than the 54th term, So again, there are two approaches to finding this. I know I can find the 54th term and then add 132 to it and then find the value of n. or I can simply frame the equation right now. So Tn is 132 more than T54. Now Tn is given by a plus n minus 1 times t is equal to 132 plus the 54th term is a plus 53d. Now from both sides a cancels, right? A goes away. And therefore what we now get is n minus 1 times d. So d here is 15 minus 3 or 27 minus 15 or 39 minus 27, that is equal to 12. So n minus 1 into 12 is equal to 132 plus 53 times 12. Therefore 12n minus 12 is equal to 132 plus 53, 12s are 626. And therefore 12n is equal to 132 plus 12 is 144. 144 plus 636. Therefore 12n is equal to 780. And therefore the value of n is 780 divided by 12, which is 65. Therefore the 65th term is going to be 132 more than the 54th term. Now the second option is I can first find the 54th term. So let us solve this question by another method. Let us first find T54. So T54 is going to be a plus 53d, and that's going to be a is 3 and 53 times d is 12. So this is going to be 3 plus 53, 12s are 626, and therefore this is going to be 639. So the 54th term is 639 and Tn is going to be 132 more than 639, and therefore Tn is equal to 771. So Tn is a plus n minus 1 into d is 771. A is 3 plus n minus 1 times 12 is equal to 771, which means that 12 times n minus 1 is 768, and therefore n minus 1 is 768 divided by 12 is 64, which means n is equal to 65. So we get the same answer no matter which strategy you follow, and this is how we attempt this particular question. Taking a break. Moving on to the next question. In the following question, it's given that the 8th term of the AP is 31. So let's note that down. It's given that T8 is 31. And the 15th term is 16 more than the 11th term. So what it means is the 15th term is 16 more than the 11th term. So that is T11. Which means T15 is 16 more than, that is 16 plus T11, right? So these are the two equations that I have. And now I should be solving these two equations. So I will start off saying, let A be the first term. Let A be the first term, and let D be the common difference. D be the common difference. So now let us see how to solve this particular question. So let us frame the equations. So T8 is going to be A plus 7D is equal to 31. That is my first equation. And the second equation that I get is T15. So T15 is going to be A plus 14D is equal to 16 plus T11 is A plus 10D. And now I can solve this equation for T. So A and A cancels from both sides. And therefore 14D minus 10D is equal to 16, which means 4D is equal to 16, and therefore the value of D is 4. Right? And now I can substitute. So I can say substitute D equals 4 in, say, the first equation. You will get A plus 7 times 4 is equal to 31, which means A plus 28 is 31, and therefore the value of A is equal to 3. So the first term of the AP is 3 and the common difference is 4, and this is how we can find the AP. Therefore the AP is going to be, the first term is 3, the second term is A plus D, that is 3 plus 4 is 7, then 7 plus 4 will be 11, 11 plus 4 is 15, and 15 plus 4 is 19, and so on, right? So this is the required AP, and this is how we solve this particular question. Again, framing the equations and using the general term, I was able to find the values of A and B. So again, pausing for a few seconds before moving on. So let's take a look at the following question. The AP is 20, 19.25, 18.5, 17.75, and so on. So for the given AP, A is equal to 20. Common difference is the difference between the second term and the first term. So that is 19.25 minus 20, which is equal to minus 0.75. And now we have to find which term is the first negative term. So basically there is some nth term which is less than 0, right? So let us do one thing. Let us assume that, let us find the value of n for which the nth term is going to be equal to 0, right? So let us find which term of this sequence is going to be 0. It is quite possible that the 0 will not be a part of this sequence. But let us assume for the time being that 0 is a part of the sequence, and let's find which term equals 0. So Tn is given by a plus n minus 1 times t, which is equal to 0. Now a is 20 plus n minus 1 times minus 0.75 is equal to 0, which means 20 is equal to 0.75 times n minus 1, and therefore 20 is equal to 0.75 is 3 by 4 times n minus 1, which means 80 upon 3 is equal to n minus 1, and therefore n is equal to 83 upon 3, and therefore n is equal to 27.66, right? Which means that the 27.66th term of this AP is equal to 0. So the 28th term, therefore the 28th term of this AP is going to be the first negative term, right? So the 27th term is going to be close to 0. The 27.66th term is equal to 0. But we know that n cannot be 27.66 because n has to be a natural number. And since the 27.66 term is 0, I can conclude that the 28th term is going to be the first negative term. So if you notice, the AP is decreasing here. So at some point the term is going to be negative, right? And the 28th term happens to be that first negative term. So the idea that we adopted here was, we found the value of n for which the nth term was 0, and then we took the next natural number which was beyond that particular value of n to be the answer. So n equals 27.66. So what it means is, on the number line, this is 0, right? This is positive term. So the 27th term is going to be somewhere over here. The first term starts from 20. So this is 20. This is where the first term starts. Then this is the second term. This is the third term on the number line. This is the fourth term on the number line, and so on. So the 27th term is going to be positive. The 27.66th term is 0. So this is 27.66, and the 28th term is therefore going to be the first negative term. So this is how we solve this particular question. I hope you understood the idea used in this particular question, and I'm going to pause for a minute before I move on to the next one. In this question, we have to find how many two-digit numbers are divisible by 7. How many two-digit numbers are divisible by 7? So let us now first find those two-digit numbers which are divisible by 7. So which is the smallest two-digit number divisible by 7? The smallest two-digit number divisible by 7 is 14. So this is the first number divisible by 7. Then 21 is also divisible by 7. Then 28 is also divisible by 7. And this continues till, so I am trying to see the biggest two-digit number divisible by 7. So let me divide 100 by 7. or maybe 99 by 7, right? 99 is the largest two-digit number. 99, so 7 ones are 7 and 2 nines, 7 fours are 28 and 1 remains. That means when I divide 99 by 7, 1 is the remainder and therefore 98 is the largest two-digit number divisible by 7. So now we have to find how many numbers are these, right? So this forms an AP. So this therefore forms an AP in which the first number is 14. So A is equal to 14. And the last number, that is the nth term, is 98. And the common difference is 21 minus 14, which is equal to 7, right? So I know that Tn is given by A plus n minus 1 times t. And Tn is 98. So 98 is equal to A plus, that is 14 plus n minus 1 times 7. Now 98 minus 14 is 84. So 84 is 7n minus 7, which means 7n is equal to 91 and therefore the value of n is equal to 13, which means that there are 13 two-digit numbers which are divisible by 7, right? So the way I solved this was I first found the minimum number and the maximum number that satisfied the criteria. And these form an AP because divisible by 7 means the difference between two consecutive numbers has to be 7 and therefore it forms an AP. And then I use the concept of general term to find the value of n. So from this I found that 13 numbers, 13 two-digit numbers are divisible by 7. Are divisible by 7, right? So this is how I solve this particular question. Pausing for a minute before I move on. Moving on to the next question. Find the numbers between 50 and 500 which are divisible by 7. So again, I'm trying to think of the number beyond 50. Now when they say between 50 and 500, it means that both 50 and 500 are not included, right? So this first number beyond 50 which is divisible by 7 happens to be 56. The next number is going to be 63. So 63 is also divisible by 7. And this continues, right? And now we want to find the maximum number. So let's do one thing. Let us take 500 and let's divide it by 7. I'm using a simple idea that I'm finding the remainder in each case and I'm subtracting the remainder from the given number. So I can start off saying 7 sevens are 49, 10 remains, 7 ones are 7, 3 remains. So when 500 is divided by 7, the remainder is 3 and therefore 500 minus 3 should be divisible by 7. Should be divisible by 7, right? This means that the last number which is divisible by 7 is 497. So in this particular AP, I know that A is the first term which is 56. D is the common difference which is 63 minus 56 and that is equal to 7. The nth term is 497. So I know that for an AP, I can say that nth term is equal to a plus n minus 1 times d. The nth term is 497, which is equal to a. A is 56 plus n minus 1 times 7. And therefore 497 is equal to 56 plus 7n minus 7, which means 497 is equal to 56 minus 7 is 49. 49 plus 7n. And therefore 7n is equal to 497 minus 49. And this value is going to be 448. So 448 is equal to 7n, which implies that n is equal to 448 divided by 7, which equals 64. And therefore I can say that there are 64 numbers. There are 64 numbers between 50 and 500. Between 50 and 500 that are divisible by 7, right? So again over here I found the minimum number and the maximum number that satisfied the criteria, and then using the idea of general term I was able to find the number of terms. Pausing for a minute before I move on to the next question. Moving on to the next question. Find the number of 3-digit numbers that are divisible by 4. So now we have to find the 3-digit numbers. How many 3-digit numbers are divisible by 4, right? So let's start with the smallest 3-digit number that's divisible by 4. I know that the smallest 3-digit number is of course 100, right? And is 100 divisible by 4? Yes, I think 100 is divisible by 4. So I can say that the smallest 3-digit number divisible by 4 is 100. And therefore the next numbers are 104, 108, 112 and so on. Now I want to find the biggest 3-digit number that is divisible by 4. So I can take 999, which is divided by 4. 4 2s are 8. 9 minus 8 is 1. 9 comes down. 4 4s are 16 and 19 minus 16 is 3. 9 remains, and 4 9s are 36. So a remainder of 3 remains. So when 999 is divided by 4, the remainder is 3, and this implies 999 minus 3, which is 996, is divisible by 4, right? This is what it means. So 996 is going to be the last term of this particular sequence. 100 is the first term. So maybe I should include 100 as well in this particular sequence of numbers. So this is 100, 104, 108 and so on. Therefore 100 is my A. The first term is 100. The common difference here is 104 minus 100 is 4. And the last term is 996. So now if I want to find the number of terms, basically I have to find the number of terms is going to be n, right? So I use the general terms formula. Tn is a plus n minus 1 times d. Now Tn is 996, which is equal to a. A is 100 plus n minus 1 times d is 4. And now I can solve this. 996 is 100 plus 4n minus 4, which means 996 is 96 plus 4n. And this implies 900 is equal to 4n. And solving for n, I get n equals 900 by 4 is 225. Therefore I can say that 225 numbers or 225 three-digit numbers. Let us correct this. So 225 three-digit numbers are therefore divisible by 4. This is how I solve this particular problem. So again, pausing for a minute, take a look at how I approach this particular problem, and then we will go on to the next question. Moving on to the next question. Okay, the next question reads, how many three-digit numbers when divided by 9 leave a remainder of 1? So now we have to find those numbers which when divided by 9 leave a remainder of 1. So let us consider the smallest three-digit number. So let us consider 100. Let's divide it by 9. So 9 11s are 99 and the remainder is 1. So 100 for sure leaves a remainder of 1 when divided by 9. So the first three-digit number which when divided by 9 leaves a remainder of 1 is 100. And now let's take 999, right? So 999 is divisible by 9. The quotient is 111, right? So therefore I know that 999 is divisible by 9. And therefore 1000, if I add 1 to this number, so 1000 will leave a remainder of 1 when divided by 9. However, the problem is 1000 is a 4-digit number. We want only 3-digit numbers. So 999 is a multiple of 9. Now let me go one multiple prior to 999. It is going to be 990. So 990 is also divisible by 9, which means that when I take 991 and divide it by 9, I am going to get a quotient of 110 and the remainder is going to be 1, right? So 991 is therefore the largest 3-digit number which when divided by 9 leaves a remainder of 1. Now 100 and the next number is going to be 109. You will notice that now I will have ops of 9, correct? So 100, 109, let's check quickly. 109 when divided by 9, I know that 9 12s are 108 and the remainder is 1. So 100, 109, 118 and so on. These are the numbers which when divided by 9 leave a remainder of 1. So this is definitely an AP where the common difference is 9. I know that this is an AP. This is an AP with the first term equal to 100 and the common difference equal to 9 and the nth term is equal to 991, right? And therefore I can say that the nth term is a plus n minus 1 times d, which means 991 is equal to 100 plus n minus 1 times 9, and therefore 991 is equal to 100 plus 9n minus 9, and therefore 991 is equal to 100 minus 9 is 91 plus 9n, which means 900 is equal to 9n, and therefore I know that n is equal to 100. So there are 100 numbers which when divided by 9 leave a remainder of 1. This is how I approach these questions when I am trying to find the maximum and minimum values. I am basically using the simple idea of dividend is equal to divisor into quotient plus remainder. So whenever I get a remainder, I have to basically subtract the remainder from the dividend to make the number perfectly divisible by a certain number, right? So this particular idea is being used in each and every problem. Whenever you are trying to find the number of terms that are divisible by some number, then this particular idea is definitely used. Okay, so this is the last question that we have today. I'm going to pause for a minute and then we end our today's session over here. Pausing for a minute. Ending today's session over here.